Imagine this purely made-up scenario, where you want to watch this new series that is coming out soon on this streaming service. Let's call it Getflix. Now, I don't have a subscription for this purely hypothetical streaming service, but I know someone who does. But I can't really use their account, because Getflix uses your IP address to detect whether you're in the network that is associated with the subscription's account. So now I obviously have two logical options. Either I can pay $4.99 per month to buy an extra slot on the subscription, or I can spend many hours of my life and $50 making my own VPN and tricking Getflix. Now, I'm not actually making a VPN protocol, since there are actually great open source protocols and libraries for this. I'm only making a VPN framework. This framework handles things like VPN node registration, client-to-node communication and information transfer. Here's how the framework works. The server is the place where each node registers itself. Then a client can just ask the server what nodes are there, what are their IP addresses, how do I reach them, and so on. Now you may be asking, what is a node? A node is just a relay on the VPN network. It's like when you have a free VPN and connect to the London server. In my framework, everything can be a node. A private network, an enterprise network, a free Starbucks Wi-Fi. You just have to have a device that is in that network and that is registered to the server so it can relay the web traffic of a client. Now, the most important part is obviously the client, the app you use to actually interact with the service. The client of this VPN comes in two flavors. I did cook up a command line interface, but there's also a GUI for those who don't use Vim as their default editor, looking at no one specific. The CLI is high-end, handcrafted, whereas the GUI is, let's call it vibe-based. Because the second I was thinking of making a GUI, I was like, no, that didn't go well in the past, I'ma let AI do it. I can't deal with this. No. For the implementation part of this framework, I chose to implement this in Rust. Now, besides some private reasons for using Rust, I want to get to know Rust better, because as of now I only vibed Rust and completely guessed when I got a compiler error. Like, what the f do you mean I can't use this variable because there exists a mutable reference to it? Do I just add an %, or what the f is going on here? For the VPN protocol, I opted to use WireGuard, because after extensive research, I've seen your ChatGPT prompt, it seemed like the most modern and usable. The server mainly consists of a small HTTPS server that just holds information about each node that tries to register itself, like IP, port, the node ID, and so on. It also handles stuff like a client wanting to see what nodes are available and the actual request to connect to a node, which is handled over a persistent WebSocket between the server and the node, since that process needs information from both the client and the node. It obviously exposes all the relevant endpoints to the client and to the node, yada yada and so on. The most important and interesting part though is encryption. Since I want this to be accessible but also secure, I opted for a self-signed TLS certificate. Now, this also has implications for the client and the node. Since there is no trusted CA that signs the certificate, the client and the node either have to trust the certificate's fingerprint on first connect, kind of like SSH handles this, or the client and the node have to be supplied the specific fingerprint of the certificate in order for the client and node to be 100% safe against man-in-the-middle attacks, although this is very unlikely to occur. The node is just a wrapper for the WireGuard CLI, since of course there are no Rust bindings, because why would there be when I can just suffer? Because of this, I basically had to maintain a Linux and a Windows way of doing things, because again, why would there be a unified way of doing things? You might now hear Windows and Linux and see one of the big three missing. Yeah, I decided not to support iOS, because fuck Apple. And because I couldn't be bothered. I did already mention that you need to have a device connected to the network that you want to use as a proxy. This is kind of a problem, because you don't really want to have a whole PC running 24/7 just so you can run a simple VPN, at least not in this economy. That's why I bought a small Raspberry Pi. So you can just load the node program onto that, configure the server host and password and connect it to the target network. Then the node will automatically register itself and each client connected to the server will be able to use that network as a proxy. This also means that, at least in theory, you could easily use a free Starbucks Wi-Fi as a valid node in your VPN network just by hiding a small Raspberry Pi in your local Starbucks. though I obviously don't condone this, guys. Now, I can just give this Raspberry Pi to my friend who has a Netflix account, and I will be able to watch my favorite shows again without paying any subscription fees, at least until Netflix upgrades their protection again. The client, as I already mentioned, is split into a GUI and a CLI, so that everyone can use this tool how they want to. The CLI is designed for those who just want to look at text all day, but the GUI is high-end, purely vibes-based, and implemented in Tori. It's modern, it's clean, it has a dark mode, like what more could you want from a GUI? It was perfect. One could say it's absolute cinema. Fuck me, that joke was bad. Holy shit. But after teasing you for so long, I present the GUI. But how do you actually use this tool now? Now that everything is covered, you may want to use this tool yourself and create a small VPN network yourself, so that you may also watch movies for free or hide your real IP address. This whole project is open source on GitHub, where you will also find a README with further instructions on how to download and use this tool. But in a nutshell, you just download the server program to a server connected to the public internet on a stable IP. Then you just download the node program to a small PC in the target network of your choice and configure the server's host, password, and so on. Finally, you just download the client program to your PC, and then you should be able to enjoy your VPN network. If nothing goes wrong, which it shouldn't, because I'm a god-tier programmer. Bro, look at me, okay? ChatGPT verified, guys. I'm ChatGPT verified, I'm so good. In reality, there are a few more checks you have to make in order to fire up the node and the server. Definitely check out the README for more detailed instructions, or ask your local LLM provider for help. But here's a quick overview of things you'd have to do. Unlock TCP port 4269, nice, on the server network. Unlock UDP port 51280 or another port of your choosing on the target network. Configure the node and the server. Run the universal install, see GitHub on more information. And finally, you can enjoy your VPN. On this way through Rust and VPN technologies, I did learn quite a lot of things along the way. Of course, I got to know Rust better, but I also dipped my toes into the chaos that is networking. Linux and Windows specifics were, of course, not enjoyed but suffered through. But hey, now I at least know a thing or two about this shit. I also got a bit deeper into Rust specifics, like why the f*** I have to implement deresmat for a wrapper type in order to have an idiomatic autosave that fires when my mutable CLI save state goes out of scope and is dropped, or why I have to use an arg of a read-write lock to have a synchronized state on Axum and in memory. But the real treasures are the friends we made along the way, or some shit like that, I don't know. Guys, it's me from the editing. Please subscribe. I have no subscribers. I'm poor. Guys, please, I need some money. I spent $50 on this. Please subscribe.